My name is Joel Edwards. I'm at JTech. Today we're going to be talking a little bit about aerodynamics and how they may affect a vehicle. So here we have a model of a Lamborghini Murcielago. It's designed with aerodynamics in mind. As you can see, is one continuous line going across. So when it's driving, the pressure is pushing this way, but it's at such a sloped angle. It's at such an acute angle that instead of the standard 45 degree or 90 degree, we have a Lamborghini Murcielago. It's definitely designed with aerodynamics in mind. If you look at the way the wind hits it, it kind of cuts through here, and this wind is actually forced down onto these small air dams, pushing the front of the vehicle down, while still having a very sloped front end, as opposed to a standard vehicle, which would have more of a sharp angle going up, causing resistance and a turbulent flow as it comes up and over the top of the vehicle, whereas this one neatly allows it to glide along. So if you keep following the air, it comes down here. The negative pressure zone on this vehicle is actually quite small if you look at the way it goes from the roof to the fastback. And if you follow these lines here, you'll see this one comes out and the air just keeps going. And as with this bottom piece here, it places that low pressure zone very far back from the vehicle, giving it less drag. So that's how it would be on something like a supercar. Then we have something a bit more affordable, Subaru Impreza STI. It does have a hood scoop for allowing air into the engine. The problem with it is that because it's sucked in here, we got this sharp angle here, and you got this turbulent low pressure zone here, as well as the slightly more angled but not as angled as a standard car windshield, air hitting it, pushing down on the car, creating a turbulent flow up here. But as it follows here, you can see that they've added this wing, not a spoiler, away from the car. Now, whether or not it actually is functional on these cars, I'm not sure. But for all intents and purposes, let's say this one is. So this wing here is separate from the car, away from this whole low pressure, turbulent, nasty zone down here, getting the air straight from here, hitting that. And you see the bumper up here, down here, also turned up to meet with this wing to bring the low pressure zone farther back, probably around here. So that's some rough aerodynamics. Now you can see that this car is much lower and has a lot of side skirts and venting and what have you. Maybe if I can get it to focus. So being lower, having side skirts, it's actually trapping negative pressure under the vehicle as it goes through. Whereas this one sits up much higher and it's not doing as much, but probably more than a standard production car. Alright, so as you can see from the two slow motion tests, you can see how the air easily goes over the Lamborghini with the aerodynamic shape in mind. With the smoke test, a little closer. So as you can see from the smoke test, the Lamborghini did much better on the aerodynamic test. The wind just kind of just washes over it and it just kind of slices through the air. Whereas with this one, you see a lot more turbulent forces at work, especially around the top of the cabin and the back area by the wing, as well as just behind the hood scoop. You can barely see it, but it does kind of like to stick around there. If you're looking under the vehicle, you're going to have that pressure almost pushing up on it. Whereas this one, so as you're watching it move all around the vehicle, you can see it just cutting through the air. Not really posing much of any resistance at all.